Evan Reese here. Make connectors are one of the Onshapiest things about Onshape. And if you're coming from another CAD system, they will seem pretty unfamiliar, but I hope that you warm up to them really quickly because they are extremely powerful and you'll be really impressed, I think, with what they are capable of. So in a previous video that you can go and watch, I talked about using make connectors for their intended purpose. The reason they were invented is to attach things in assemblies. But as the software has matured, they have become increasingly powerful for modeling and supporting many other workflows. So I'm going to get into all of that today. We're going to do everything except for using a make connector as a make connector. All right, so the super short version of that last video was that a make connector is a coordinate system. And by that, I mean there's an implicit origin here, and then there's X, Y, and Z axes. But what I didn't mention is that it's kind of an amalgamation of many different types of datums. So a make connector can be used as a plane. You can sketch on a make connector. A make connector can be used as an axis. You can use it to revolve around, and a make connector can kind of be used as a point, for example, to place holes with the hole feature. And that's a really powerful multi-tool that you have at your disposal. And on top of that, make connectors are not just a feature that you use to create something. There is a make connector feature, but so many features, including many custom features in Onshape, allow the kind of on-the-fly creation of a make connector. A prime example being the sketch tool. So if I Shift S to create a sketch, look, I've got this icon here, or Control M. I can click that icon, and suddenly I am inferencing all over this part, and I could sketch anywhere. And I mean, I can even sketch on a curve or something. And, I could sketch in the middle of one of these studs, which there's no actual planar face that would allow me to do that on this model. But I don't need one. So make connectors are really great for that. But beyond that, I can actually click the icon here once I've begun to create one, and I can modify this thing in all kinds of ways. So imagine that I actually want to sketch offset from the top of these studs by 1 millimeter. I can do that. I can offset the Z direction. And now I am suddenly sketching on a plane that wasn't there. I can snap to the origin of that make connector and put a circle up here in space. I didn't have to create any geometry in the feature tree, and it was very quick and intuitive to do. I do want to actually have a quick note here about inferencing. So if I open this and I'm mousing over this, you'll see all these little dots show up and make connectors are snapping around. And it can be a little bit tricky to get exactly the item that you want. So the trick for that is to remember that you have the Shift key. So I might be trying to grab this and then, oh, I moused over the edge or that face or something like that. So I'm just going to mouse over this face and hold Shift. And now it does not grab any other geometry. So that's a good way to kind of control when you are and are not inferencing something new. So let's say I actually wanted this cylinder. I can inference that instead. Okay, so that's how you can create make connectors on the fly. Let's get into some of the workflows for this. So I use them a lot for cases like this, where I have a curve. This one is kind of in random 3D space, not oriented to anything in particular. And I want to create some geometry around this curve. So I can grab my make connector tool, or even better yet, just Shift S for sketch and begin to inference this curve. I'm holding Shift, and I'm now sketching on a curve that is normal to the curve at that point. C for a circle, and now I have a profile that I can put on this curve. I'll do another one up here, and that's on the end of that curve. I'm going to drop just a single point here. And then if I loft between the two, I can loft to that point, and I'm getting this really spiky spike. I can use the curve itself as a path, and I'm starting to create some sort of horn. And because that point is not just the end point of this curve, it is actually a sketch point. It then therefore has an implicit sort of normal and tangent direction. So I can go tangent to profile. Oh, that's for the start. Let me do it for the end. Get rid of that. Tangent to profile. And I can start to kind of round off this horn a little bit. If I were going to 3D print this or something, I probably don't want it super spiky, and I also don't want it to have a blunt flat end. So that's a quick way to create something like that. Make connectors, also being coordinate systems, are fantastic for transforming objects around, moving them around. So I can grab the transform tool, And it's always best practice to model things where you want them in space. But imagine I had imported this and it was just out here in the middle of nowhere. So I can transform this entity by mate connectors. So I can choose from a mate connector, this one, to a mate connector, that one, on the origin. And it's upside down, so I can use A to flip it. And if I wanted to, I can use Q to rotate it by quarters. And if I wanted to edit either of these more precisely, I can certainly do that as well. I can rotate it to any position that I want. Really great way to place things in a part studio. Oh, another great way that I have used mate connectors in the past is just as a quick way to create part stackup to sketch on. So if I were modeling, planning to model an electronic enclosure, here's one way that I might go about it. I'm going to grab my lines and just draw up. So I have these each represent a certain thing in my part stack up. So the first one's going to be my wall thickness, then I'll have a gap, then I'll have a circuit board, then I'll have a bigger gap, and then I'll have the outer wall on the other side. So then I can come in and dimension these. That'll be nominal. I'm just creating variables as I go. So let's say it's a 2mm nominal thickness. This will be a pretty small device. Then the gap is going to be PCB gap, and that'll be 0.5mm. Let's see. PCB thickness is going to be 1.6mm. Enclosure space is the space above the circuit board. Let's give it 2mm for components and whatever else. And then this one is going to be the nominal again. So there you go. Now I have a single sketch that defines my design. So if I then wanted to come in and create my circuit board, I can sketch right here. And let's say that my circuit board happens to be 25mm by 30mm. I can extrude that up to a vertex, which is here. So that's my PCB. And then, maybe the enclosure itself is going to be, I don't know that I would actually model it like this, but I'll show it to you for now, just for speed here. So I can extrude it up to the inside face of the enclosure, make it a new body. Second in position will be the other inside of the enclosure. So that's kind of the cavity inside the part. I could even use a move face to create a little bit of space around that circuit board. And let's say PCB gap is going to be the same variable I used there. And then I can use the shell feature set to hollow, flip it inside out so it goes outward, and set this to nominal. So now I've quickly created a part stack up that is fully responsive. So I can change the variables, but they're all hanging on this one sketch. So I have one place to edit the things that I want to edit. Partially empowered by mate connectors. It's a good way to work. Another really cool thing about mate connectors for modeling is that you can use them as a point. So if I grab the hole feature here, it says sketch points to place holes, but really you can also just click this button and use a mate connector. So there we go. I've got holes here, here, here. Get rid of the middle one. All right, there's that. And then I can also use a mate connector as an axis. If I go circular pattern, I can pattern this entity, let's say 3 times about. I'm going to hold shift while I mouse over the origin. And then as soon as I've got it bullseyed, let go. And there we have it. Set it to add, and these will merge with themselves. So now I've created this plate. And something we can do, let me take it to the next level here. I'm going to also create a mate connector here, and it automatically selects an owner entity. So it's now attached to this part. If I bring it to an assembly, it will have this mate connector. Shift enter to make another one. All right, and then I'm going to also circular pattern those. This one will be 6 times. And if I could certainly set up a variable to do this, so that they're always connected. That would be what I would actually do in a real model. But for the demo, we are going to call that good. And then just so that we can tell the faces apart for what I want to show next, I'm actually going to chamfer this edge. All right, so now we have that one edge chamfered. So if I bring this into an assembly, you can see we've got all of these mate connectors. And because I patterned them, they're actually oriented to the hole the same way all around, which is nice. And I can use that to mate this to the origin, for example. But mate connectors can also be used to position parts when you derive them. So the derive feature is a great way to bring parts from one part studio to another part studio to continue doing things with them downstream. It's used for master model workflows, but also for some other stuff that I'll show you in a little bit, actually. You can use it like this. I'm going to bring in that part we just made, holes and axes. So by default, it brings it onto the origin, and I can place it using, here we go, in this dialog here, it only takes mate connectors as an input. So I don't even need the icon. I start mousing over stuff and I can place multiples of these. It'll warn me this is not for patterning, and I agree. I would not use this to create patterns of parts. That's best done in the assembly. But the mate connectors can also be used to decide what the origin is. So I can choose, instead of placement base origin, I'll choose base mate connector, and I get all these dots. So now that mate connector becomes the origin. And if I click this one, it becomes the origin. And you'll notice my chamfered edge moves over there. So I can choose from any of the mate connectors that are attached to this part as to where I'm going to bring this in, which is a really, really handy way to work. All right, let's put some of that together. And we're going to build this sort of vasey thing together. It's pretty quick, so let's just get rid of all that, and we're going to use mate connectors in a few different ways. So a lot of times when I'm just slapping geometry out for demos, especially, I like to use my cube custom feature. It'll drop it on the origin. There was a fun feature that Michael Pascoe wrote called Topogriphinator. So I can pick this face, and it'll go ahead and stack these up. Let's do a layer thickness of 0.5 and 10 layers. Yeah, sure. That looks great. So now I have this separate part. And I'm going to use another custom feature called Transform Pattern by Constantine. Sorry, I don't know your last name or how to say it. All right, we're going to pattern the topographinated part. My reference point, I'm actually going to choose this top face, and then I'm going to hold Shift and inference it. I'm going to grab the middle of that face. And then I can hide that part because I don't need to see it. And then for the places to place the mate connectors, I'm going to grab this button and start placing. Now you'll see that it's kind of set in because I grabbed actually that first face. That's what I want. But I want it to go the other way. I'm going to flip the first mate connector. And now I can start to place. I can use a remove command with this as the scope. All right, I think you can see where I'm headed with this now. So there's that. I'm going to leave the bottom in case, this was 3D printed or something. You'd want a nice stable base. Then I might, for example, just extrude this. This is a little bit fast and loose, but it's a good way to go. I'm going to go up to that face, offset by 4 millimeters, let's say, and I'm going to draft it. And I want to see what I'm doing. So I'm going to use my hotkey that I set up to see the inside and crank the draft to something good. All right, now we've got a nice hollow inside of there that could potentially hold water. And let's see, lastly, I'm gonna pop my logo on here, also using a mate connector. So I'm gonna hit Shift S and use a mate connector on, let's begin with this face. And I can go DXF. I've already got the logo imported. So let's get that put in there. And you can see it's coming in pretty small. I'm gonna box select the logo and go transform. I want to transform it actually about that mate connector, not about that point. So I can grab the middle of this little gimbal, snap it to the mate connector, and then scale this thing up. Something like that. And it's upside down. So I could use the transform tool to flip it, but I actually would rather have it oriented correctly because the mate connector is oriented correctly. So in a sketch, the green axis will be vertical and red will be horizontal. And that is true even if the mate connector itself is not aligned with the world axes. So let me show you what I mean. I can rotate this sketch at any angle that I want, which is really nice for doing sketches of things that, would be rectangular, but they're off at a weird angle. And so you can't use your horizontal and vertical constraints. If you do it on a mate connector and orient that mate connector, then you suddenly can. In this case, I don't need to actually change this angle. I just need to clock it around twice. And then lastly, I would prefer to center this visually, not geometrically, meaning like, these sort of imply a circle, the center of which is there. But graphically, I think it looks a little better down a little farther. It's almost like using the center of gravity of the part to get a better visual alignment. All right, now I have that sketch. I can Shift E to extrude it, and let's just do it by 0.5 millimeters. And then from that, I can create a circular pattern, feature pattern of that feature. And the axis, I'm turning on the origin here, holding Shift while I mouse over the origin, snipe it. There we go. So that's using mate connectors in a bunch of different ways. And you'll notice that there are no actual mate connector features in my tree, but they really made this model possible in some cool ways. All right, one other really incredible feature that I want to show is the super derive feature. And this one can be so valuable. So I am modeling a bearing block, and the geometry that I need for each bearing is going to be identical. And I don't want to have to sketch it in one place and then try to linear pattern it around. And this is especially important if I am having these bearings all over a project and this same geometry occurs in multiple part studios or maybe even multiple documents. It is really a bad way to work to model those manually every time. So instead of doing that, I actually modeled the bore, the bearing bore, including a groove for a circlip, so I can assemble this thing. And what I'm going to do is create this sketch. And that sketch is just there to give me something to inference. And then I'm going to use a feature called super derive. There you have it. And I'll put a link to this custom feature and all the other ones that I've used in the video description. So go check there. So I'm going to select a part studio and pick the bearing bore. Now, if you were doing this for your company, you could have a whole library of repetitive geometry like this, and you could configure the bearing bore with a dropdown that has the part numbers of the different bearings you're using. You could get pretty detailed with it, and I would recommend doing so. I'm going to choose just this object, not the whole thing, because I don't want to bring in the sketch as well. All right, so the beauty here is we have locations. Again, I'm going to hold Shift, and I'm going to pick that edge. Pick each of these in turn. And the thing I love about super derive is it has Booleans built into it. So I can subtract these out as I go. So I'm getting those. I can mirror that feature about the front plane. So now I have those holes on the other side. And then I can see Shift P to hide the sketch and hide all construction geometry. I can grab these faces, Shift E to extrude, remove through all. Great. So now we have this part ready to receive those bearings. And if I update just this, all of those will update across my whole project. All right, so let's put those together then. Here we go. So we have the block in here, and I can go Insert. I'm going to leave Snap Mode on, which you may have seen from the previous video. The bearing is actually a composite part because I didn't want to go to the trouble of Booleaning it together, but I also just need it to be one item in my bill of materials. So then I can come in here and choose any number of things that I want to snap to. I could choose that. I'm actually going to choose this face here, the inner circular face, holding Shift. Now I have these 3 points that I'm inferencing, and I'm going to grab that one. Next, I'm going to get the retaining ring, and again, I have snap mode on, so I'm inferencing, and I'm going to grab the center of that little race because I know that the mate connector I made in the retaining ring part studio is also on the center. So now that is mated, and I can use the replicate command. So let's start with the bearing. Because I was careful about choosing that particular face, it says match faces in parts. So I can click this part, and any face that's identical to that one, it will mate. So now I have bearings there. Shift Enter to reinstantiate replicate, make a second version. The circlip is my instance, and again, parts to find match in. So now we have fully assembled our bearing block in a pretty quick and straightforward way. And if I needed to change the bearings out or the bore or any of that, it is not impossible and not even that hard to set up a part studio that has a configured bearing, a configured circlip, and a configured bearing bore, so that at the assembly level, I could choose from a dropdown if that was something that I wanted to be able to do in the assembly. So there you have it. There's a ton of ways that you can use mate connectors, not for connecting things in an assembly, They are one of the most powerful and hidden tools in Onshape. Thanks for watching.